I want to talk about how we can determine or calculate the equilibrium constant for a weak acid or a weak base. So there's several ways that we can do this. One approach is we can dissolve a known amount of weak acid or base, and we could measure their pH. We could also, right, in these types of problems, be given the pH and given some information that allows us to get the equilibrium concentration of the acid or base in their ionized ions. So then we can calculate Ka or Kb. So I want you to spend some time thinking about like what are different ways we can do this, right? We have done this in experiment 6, where you were actually determining the equilibrium constant for a complex ion. So same idea here, right? Think about what information you were giving and what you had to find in order to find the equilibrium constant. So let's look at one example. So acetic acid is a common weak acid that we will constantly talk about, right? This is the main ingredient in vinegar that is the reason for its sour taste. So at equilibrium, a solution contains the following concentrations, right? So we have the concentration of acetic acid. They also tell us the concentration of hydronium ions as well as acetic acid's conjugate base concentration as well. So we want to calculate the value of Ka given these conditions for acetic acid. So the first step, we want to write our equilibrium reaction, like what is happening, right? To make sure that we have our stoichiometric coefficients correct. So this is acetic acid. When it is dissolved in water, it will form, right? So acetic acid, it's an acid. So it is donating a proton to water. And that's how we end up with hydronium ions. As a result, acetic acid will form its conjugate base, which is minus the proton that it donated. Acetate, right? Which is its conjugate base. So here is our equilibrium reaction for dissolving the weak acid, acetic acid, in water. So we want to get Ka. Well, they told us what the equilibrium concentration is of acetic acid, of its conjugate base acetate, as well as hydronium ion. So when we write our Ka expression, it will be H3O plus times acetate over acetic acid. We have the concentrations at equilibrium for each of these, so we can just plug it in, and we have a Ka of 1.77 times 10 to the minus 5, right? Much less than 1, which makes sense because acetic acid is in fact a weak acid.